Now when we talk of the physical properties of the alkanes, so you should know that what is actually their state of existence first, because our first concern is that how they exist at room temperature. So the first thing is that if they talk about their existence, so the alkanes with carbon atom 1 to carbon 4, ranging from 1 to 4, they are actually gases, and 5 to 17 are liquids, and 18 onwards are waxy solids. And you know that whether they exist in gases, liquid and solid, all are odorless and colorless. So that means alkanes they do not have any specific odor, or they do not have a specific color even. And if we talk about the boiling point, so what happens, as you all know that alkane, there is a bond between the carbon and carbon, right? So that means it is actually non-polar in nature, because there is no electronegativity difference that exists between, because they are homonuclear. So what happens, so there is no electronegativity difference, that means obviously it is a covalent bond, but out of that it is a non-polar one, right? So because it is a non-polar one, so that means it is not possessing any kind of strong interactions. So what kind of bond is there? It possessed only weak van der Waals force, right? So that means they have comparatively, means generally they have low boiling point. But as we increase, like when we move from methane to ethane to propane to butane, so what happens actually, the boiling point goes on increasing. As the number of carbon atom increase, the boiling point also increase. The reason being because when there is an increase in the area, surface area, obviously the van der Waals force increases with that, and somehow the intermolecular force, that means increase, so that is why the boiling point also increase. But when we talk of the branch ones, suppose I told you that suppose this is my pentane, my normal pentane, and this is my isopentane. So if I compare the boiling points of the two, so this is my straight chain and this is my branched one, so this is going to have comparatively less boiling point. The reason being same, because when it is branched, it is occupying a smaller area, it's the small area. The small area means that low van der Waals force, so that means low interaction, low intermolecular force, so that means low boiling point, right? So this is what is the boiling point. Third is the melting point. See, whenever we are talking of the melting point, we need to consider that how strong is the packing in the lattice, that how strongly it is packed. So as we have seen that like when we are, so generally we can say they have low melting point, means the packing is not too strong. But as we move from C1 to this, melting point somehow rises, because same reason, because van der Waals force actually increase, right? But what happened, like if we talk about the symmetrical alkanes and the unsymmetrical alkanes, so what happens, we get to see that the symmetrical alkanes, I'll write here so that it should click your mind immediately. The symmetrical alkanes have higher melting point as compared to the unsymmetrical one, because what happened in the symmetrical one, you can say that they can be a close packing, actually they can be made to come more closer in a lattice, but somehow we cannot have that kind of closeness in the unsymmetrical ones. So when there is a closeness, that means we get to see a different strong bonding between them, and this will somehow increase the interaction and it will somehow increase the melting point. So if we compare about the branched and the straight, about the boiling point, so we talk about that the branch is going to have less. But when we talk about the symmetrical and the unsymmetrical, that means the alkane with the even number of carbon atoms, alkane with the odd number. So that means the even one has this the high melting point, because they have somehow structured the spaces where the other carbon can fit into. So that means there can be a strong lattice. Now if we talk about solubility, we all are aware of the fact that same like dissolves like. So that because it is a non-polar alkane, as I told you, there is no electronegativity difference. So that means it is somehow soluble in the non-polar one only. So that means it is soluble in the non-polar solvents, not in the polar ones. And if we talk about the density, as you all know, density is mass per unit volume, that how close the particles are actually. So as I have told you that there exists only a weak force, so that means density is somehow less as compared to the water, because we all know that the water actually possesses the hydrogen bonding, which is strong as compared to the van der Waals force. So that means density, if we talk about the density, it is somehow less than the water. So this is our physical properties of the alkanes. Now we are going to start with the chemical properties, right?